welcome. Here we go. Today we're talking about squares and square rooting. So we've been talking about exponents and scientific notation, but square roots are going to be a way, or roots in general are a way for us to undo or do the opposite operation of exponents. And square roots undo squaring, which is the exponent 2. So get your name at the top left, date at the top right, get that title on there, and here we go. Man, you would think I would be good at this by now. Alright, so exponents tell us to multiply the base repeatedly. So again, this is just the prerequisite knowledge you need to know what exponents do to know what square rooting does. Any number raised to the second power is called squared. So I want to give a quick explanation about why do we say that. Well, if you're going to think about a square, and let's say we have a square that has a side length of 3, and you want to find the area. Well, if you're going to find the area, what you need to do is take one side and multiply it by another. So usually we do length times width to find area of rectangular figures. But a square is unique because all the sides are the same length. So we're not just going to multiply the length and the width. We're actually going to multiply a side length times itself. And hopefully you're might be beginning to see why this is going to be called squaring. And so what we're actually doing is multiplying a number times itself twice to find the area. So the exponent of 2 for a side length will help us find the area of a square. So when you multiply a number times itself, or multiply a number 2 times, we call it squaring. So that's a little bit of an explanation. Another easy way to remember it is squares are in 2 dimensions. And that's again why we multiply length times width to find the measurement of the space they take up. So 2 dimensions, exponent of 2. A number raised to the second power is squared. So that's what we need to know here. Square rooting, what that does is it asks us to find what base was squared. So in this case, we know that this area would be equal to 9. The area is equal to 9, and that's after we squared the 3. So to do the opposite operation, we would say if we're going to be square rooting, we're going to say take 9 and find out what number could you multiply by itself to get 9. And you would find out it was 3. You can multiply 3 times itself to get 9. So the square root of 9 is 3. But something people often forget is there is usually a positive and negative square root. So we know that a negative times a negative equals a positive. So you're saying, how can you multiply to get 9? What number can you multiply times itself to get 9? Well, 3 times itself equals 9, but so does negative 3. Negative 3 times negative 3 is also going to give you 9. So the square root of 9 is actually positive 3 or negative 3. Either one would be an appropriate square root. The square root symbol is called the radical. And I need to draw that for you real quick. Isn't that an awesome name? The radical, dude. So this is what the radical looks like. So you'll get used to drawing those. And so we use the radical. We've already talked about the fact that it's a grouping symbol. So the radical is a grouping symbol, and it tells us to find the square root. So let's move on to some example problems and do those together. Here we go. Number 1 says, what is the square root of 81? So to write this out, we could maybe draw 81. We can maybe draw 81 inside the radical, and we say we need to find out what is the square root of 81. Well, what number times itself equals 81? Well, 8 times 8 is 64, 10 times 10 is 100, 9 times 9 would be 81, but so would negative 9 times negative 9. So positive or negative 9, and that's the way you can write it, positive or negative. They're both appropriate square roots. What if it's a bigger number like the square root of 225? Well, if you don't know that right away, you can start and do some guess and check. You could say, well, let's do some that I know mentally. 10 times 10 is 100. That's too small. 20 times 20, 2 times 2 is 4. Put those zeros back and multiply by those 10s that we ignored. Okay, that'd be 400. So it needs to be between 100 and 400. Seems like it's closer to 10. Let's maybe try 13. Now, if you're looking, if you know your multiplication really well, you can look in the ones place and know this isn't going to work out. But 3 times 3 is 9. 3 times 1 is 3, placeholder 0, and then we get 13. 1 times 13 will give us 13. Okay, this is 169. So this is too small, so we need to bump it up maybe a little bit. Let's try 15. So you can guess and check for these types of problems is what I'm getting at. And if you're paying attention, you'll notice that these first ones digits will tell us what our one digit and our answer is going to be. So 5 times 5 is 25. This is looking good so far. 5 times 1 is 5 plus 2 is 7. And then we're going to do a placeholder 0 and 15. And what do we get? We get 225. when we add these. Sorry, I expect you guys to show your work, so I need to show mine too. So we know that 15 times 15 would equal 225, so the square root of 225 would be positive or negative 15. That's the number that, when squared, equals the number inside the radical. Great. Finally, let's look at this last one. If you want to fence 3 sides of a square yard that is 400 square feet, how many feet of fence do you need? Okay, so this is a word problem. They're actually making us think about a big yard that's a square, and it's 400 square feet. So I know that when I multiply a length and a width, if I multiply one side and another side, I'm going to get 400. So what are the lengths of the sides? What times what? What's the square root of 400? It is, we just said 20 is a good way to figure that out. You could guess and check for a while, but it's going to be 20. We're going to keep it positive this time, and they're usually looking for the positive answer unless they put a negative out front, unless they put a little negative sign, but I'm going to ask you to know both. This will be positive because we're talking about distance, so the square root of, or the side length of a 400 square foot yard is 20 feet. Each side is 20 feet. So if a side equals 20 feet, and we're going to fence 4 sides, well, or we're going to fence 3 sides, sorry. We're going to fence 3 sides, and that's probably because maybe the house is on this side, and so we're going to just fence the other 3 sides. We're going to have one side of 20 feet, another side of 20 feet, a third side of 20 feet. So we could just say that we need 20 plus 20 plus 20, 60 feet of fencing. I'll move this and make it so you guys can see, but you guys should be writing that as well. We need 60 feet of fencing. Period, so Mr. Barrett's happy with me. Okay, so hopefully you're understanding square roots, pretty basic. If not, take another look at the beginning of the video and check it out again. See if you can go step by step with me. But I'm going to leave you with these, so these are your problems to do on your own. I know there's a clear ink, so I'm going to get used to it, but not quite yet. So show me this work for these 3. What is the square root of 1,681? You're going to have to do quite a bit of guessing and checking and some mental math maybe. The square root of 64 is your second problem. And finally, if a square pool has an area of 36 square feet, that's the area of the pool. How long is each side? And it's a square pool. So do your best, and I'll see you tomorrow.